These are the rules for finding horizontal asymptotes if you're just given an equation. Because if you're given a graph, what can you do? Yeah, look, right? You can look with your eyes to find the asymptote. But if you're given just an equation, the first thing we have to look at is the exponents. That's where we have to look first, okay? We need to find the greatest exponent used in the, yes, and in the, good. In each, the greatest exponent is called the, do you remember what it's called? Do you remember what the greatest exponent is called? It's called the degree. There are three possibilities, okay? Three possibilities. Either the degree of the numerator is greater, they are the same, or the degree of the denominator is greater. Those are the only possibilities, right? If the degree of the numerator is greater, that means there is no horizontal asymptote. None. Okay? For example, can I give you an example? Yeah? Okay. If f of x is x squared plus 5x over x plus 1, what's the degree of the numerator? 2. What's the degree of the denominator? 1. Can you tell the degree of the numerator is greater? Because 2 is greater than 1. So since the degree of the numerator is greater, there is not a horizontal asymptote. Does that make sense? Okay. Go to the other side. The degree of the denominator is greater. If the degree of the denominator is greater, there's automatically a horizontal asymptote at y equals 0. So if f of x equals x plus 5, also on this example, I'm going to try to trick you. Don't be tricked. X plus 1 times x plus 3 is our denominator. X plus 5 is our numerator. What's the degree of the numerator? 1. What's the degree of the denominator? Oh, I didn't even trick you at all, did I? Why would the degree of the denominator be 2? I'd have to multiply them out, right? And x times x would be x squared, right? So the degree here would be a 2. So do you see that the degree of the denominator, 2, is greater than the degree of the numerator, 1? Since there is, well, I didn't write it on this one. This one, there's just none, right? This one, where's our horizontal asymptote? Y equals 0. Now, how did I write that? Why didn't I just write 0? What is an asymptote? It's a line, right? Yeah, some of you are showing me with your arms. That's fine, okay? It's a line. And if we're going to name a line, we name it. We don't just say line. We don't just say 0. We say y equals 0, right? Y equals 0 tells us that it is a horizontal asymptote, right? Because it's horizontal. It's crossing the y-axis. Does that make sense? Okay. Now, the last part that we have is if they're the same. If the degree of the numerator and the denominator are the same, then we look at leading coefficients. So everything in the numerator and denominator, they have to be in order, right, in standard form. But when they are, we look at the leading coefficients and we just divide them. Leading coefficient of the numerator divided by leading coefficient of the denominator. Can I give you an example of that? Okay. F of x equals x plus 5 over 2x plus 3. So let's make sure, what's the degree of the numerator? 1. What's the degree of the denominator? The degree, right, is a 1. So 1 and 1 are the same. When the degrees are the same, then I look at the leading coefficients. What's the coefficient of the numerator? A 1, right? It's an imaginary 1. So what is my asymptote here? Y equal 1/2. Good. So when they're the same, I have y equals leading coefficient divided by leading coefficient. Does that make sense? You got your 3 examples here? Yes? Okay. So let's look at the next worksheet that I gave you. I'm going to go right to the back. Notice what kind of asymptotes we're talking about now. Vertical, right? Which way does that go? Show me with your arms. A vertical asymptote goes which way? Up and down, right? Up and down. Horizontal is left and right. Vertical asymptote goes up and down, right? Okay. Vertical asymptote is going to cross which axis? Vertical asymptote is going to cross the x-axis. That's correct. Okay. So let's look at this sample table right here. What do you notice in the sample table? There's an error, right? Now, is that the only thing you notice? No, but that's the thing that kind of stands out, doesn't it? Okay. Now, for the record, it's not going to say error on our calculator, is it? It's going to say undefined. Okay. So on our calculator, when we look at tables, it's going to say undefined. What do we know after looking at this example I gave you right here of the parent function? Okay. And if you're watching this video, I'm pointing this way because on the board, we drew the parent function. Okay. What do you notice about 0 when x equals 0 on the parent function? What is y? Undefined, because 1 divided by 0 can't happen, right? So what do you think is happening right here in this table? This x value is providing an undefined, which means if I put this in to the problem, what am I getting in the denominator? 0. Okay? So this right here tells me where my vertical asymptote is. Where do you think my vertical asymptote is? Any guesses? -2? Okay, I totally agree with that. That's where my vertical asymptote is. But remember, how do we name our how do we name our asymptotes? As lines, right? And we said it's a vertical asymptote. So which axis is it crossing? X. Another way to remember that is, what column is this in? It's in the X column. X equals -2. That's where my asymptote is. That's where my vertical asymptote is. Okay? So if I have a vertical asymptote at -2, what does that tell me about my domain? What can my domain not be? -2. Can it be anything else? Yeah, anything else still lets me have part of the graph, right? A -2 lets me have an asymptote. So when I go to write my domain, it's basically everything but -2, right? So -infinity to what? -2, parenthesis or bracket? Or parenthesis, okay? Because is -2 included? No, that's where my asymptote is. So I get all the way up to -2, but don't get to -2, because then on the other side of -2, I go all the way to infinity. Does that make sense? So in the table, where there's an undefined, or in this case an error, what is that telling me? That's telling me where the vertical asymptote is. Okay? Just looking ahead just a little tiny bit, but not writing anything down for you, what do you notice about problem number 3? Are we allowed to have 2 vertical asymptotes? Yeah, we could have like 50 if we wanted. We won't, just for the record, we won't. Okay, but you could. All right? Now, if I'm telling you right now that in the table where the x, when the x is there and I get a y for an error, what is that making? What's happening there? An asymptote, right? That's where it's not living. And if we look back at the original, at the parent function over here on the left-hand side of the board, we know by looking at the parent function, it's 1 over x, because what you told me was that the denominator can what? Not be 0. Perfect. Okay? And so what we did is we looked in the table to see where it was, and where it was, it's telling me it's undefined. So instead of a table, what if I give you an equation and say, where's the vertical asymptote? Well, for some people, that's even easier, because all you do is you look at the denominator, x minus 7, and you purposely set it equal to 0. You purposely set the denominator equal to 0. So x minus 7 equals 0. If we add 7 to both sides, I know that I have an asymptote at x equals 7, a vertical asymptote. Does that make sense? Okay, so to find horizontal asymptotes, what do we do first? We look at the exponents, right? To find vertical asymptotes, what do we do first? Set the denominator equal to 0. Everybody okay so far? Okay, now look at the last worksheet, please, that I gave you. This is called removable discontinuities. You know how sometimes we have mathy math words for stuff, and then we have like regular human words for stuff? Okay, remember I told you earlier that talking about asymptotes is always funny for me because I'm a high school teacher and that's where my brain lives, right? It's even better on this one, especially because we're doing asymptotes and this in the same day, because you know what the human word for these are? Holes. Holes. So we're talking about asymptotes and holes in the same day. Can you handle that? Yeah. Okay. Removable discontinuities. Okay. Let me show you something real quick. You know that an asymptote looks like this, right? And you know the graph looks like that around it. Yeah? But here's what a removable discontinuity looks like. There's an asymptote here. There's also a hole. And you have to be able to tell the difference. Can I show you? No, you don't need me to show you? Oh, yes. Okay, okay. Just making sure. Nobody answered, so I wasn't sure. Usually values of x that make the denominator equal 0 will create what? Uh-huh.